So in this video I want to talk about the divisor function. Now in the past couple of videos in this series on the prime numbers and their distribution, I talked about arithmetic functions. And arithmetic functions were basically functions which mapped the natural numbers to the complex numbers. And in this case, the divisor function, which I'm about to define, is such a function. I also talked about multiplicative functions and additive functions and totally multiplicative and totally additive functions and what it means in cases where the arguments are co-prime, for instance. So what is this function d of n? This is the divisor function. It's one of many sorts of divisor functions, and this basically counts the number of positive divisors of n. And in this case, the word positive is quite important, because obviously if 4 is a divisor of a number, then obviously minus 4 is also a divisor, but I'm only interested in counting the positive divisors of a natural number n. Now another way of writing this, in other words counting the divisors, I could write it in summation notation in the following way. I've got d of n is equal to the summation over all the divisors m of n. And you can see that each time I find a divisor m of the number n, I just add 1. So let me just go through a few examples just to show you what I mean. So the first example asks us, what is d of 4? Well, that's basically asking what the divisors of 4 are, and the divisors of 4 are 1, 2, and 4. So how many divisors is that? Well, obviously it's 3 divisors, so we can say that d of 4 equals 3. Now we can also look at this using summation notation, and if we wanted to use summation notation, we'd basically say d of 4 is equal to the sum over all divisors m of the number 4, and in each case that m is a divisor, we'd have 1. So for instance, 1, if m equals 1, 1's a divisor of 4, so we add 1 in that case. That's when m equals 1. When m equals 2, that's a divisor of 4, so we add 1 in that case as well. When m equals 3, 3 is not a divisor of 4, so in that case we don't actually add anything to the sum, so we can skip over that. When m equals 4, well, m equals 4 is also a divisor of 4, so we add 1 in that case as well. And obviously any number which is higher than 4 can't possibly be a divisor of 4. So in this case we've got 1 plus 1 plus 1, which is equal to 3. So d of 4 is equal to 3. Let's look at another example. So the next example is d of 12. What is the value of the divisor function evaluated at 12? That's basically asking us how many divisors 12 has, how many positive divisors. The divisors of 12 are 1, 2, 3, 4, 6, and 12. And that is 6 divisors in total. And again, using summation notation, we can say that d of 12 is the summation over all the divisors m of 12, and in each case we add 1. So when m equals 1, 1's a divisor of 12, so we can add 1. That's when m equals 1. When m equals 2, 2 is a divisor of 12 because 2 times 6 is 12, so we add 1 in that case as well. When m equals 3, 3 is a divisor of 12 because 3 times 4 is 12. When m equals 4, 4 divides 12 because 4 times 3 is 12, so m equals 4 is also a divisor of 12. Might run out of space here. When m equals 5, 5 is not a divisor of 12 because 2 times 5 is 10, and we've got a remainder of 2 when you try to divide 12 by 5. So we don't add anything in that case. And when m equals 6, 6 divides 12 because 6 times 2 is 12. So when m equals 6, we add another 1. Now when m equals 7, 8, 9, 10, or 11, we don't actually add another divisor because none of those numbers divide 12 evenly. The next value of m which divides 12 is 12 itself, and in that case we add 1 as well. So we also add another 1 in the case where m equals 12. And if we add all those up, you get 1 plus 1 plus 1 plus 1 plus 1 plus 1. That's 6 lots of 1, which is 6. So therefore, d of 12 is equal to 6. Let's look at one final example. So suppose now that p is a prime number. What is d of p? Well, this one's a little trickier, but if you think about it, a prime number by definition only has two factors, itself and 1. So the divisors in this case are, by definition, just 1 and p. So, for example, the number 17 is a prime number because its only divisors are 1 and 17. That's the definition of a prime number. So in that case, d of p is just 2. So thanks for listening. In the next couple of videos we'll talk a little bit more about the divisor function, including some other nice formula we can use to calculate the value of d of n when we know what the prime factorization of n is. And later in the course we'll look at some asymptotic expansions for the summation of d of n and possibly eventually the sum-divisor function, which is an even more exotic function. Thanks for watching.